In this tutorial, I'll be showing you naming collisions and an introduction to namespaces. Let's say you are driving to a friend's house for the first time, and the address given to you is 245 Front Street in Mill City. Upon reaching Mill City, you take out your map, only to discover that Mill City actually has two different front streets across the town from each other. Which one would you go to? Unless there were some additional clue to help you decide, you would have to call your friend and ask for more information. Because this would be confusing and inefficient, in most countries, all street names and house addresses within a city are required to be unique. In a similar way, C++ requires that all identifiers be non-ambiguous. If two identical identifiers are introduced in the same program in a way that the compiler or linker can't tell them apart, the compiler or linker will produce an error. This error is generally referred to as a naming collision or a naming conflict. Let's give an example of a naming collision. Let's create a new file in our program and create a function which I will call it my function, and it will take a parameter called x, and we will create the same function with the same parameter in our main file. When the compiler compiles this program, it will compile our file and the main.cpp file independently, and each file will compile with no problems. However, when the linker executes, it will link all the definitions in our file and our main file together and discover conflicting definitions for function my function. The linker will then abort with an error. Note that this error occurs even though my function is never called. Most naming collisions occur in two cases. Two or more identically named functions or global variables are introduced into separate files belonging to the same program. This will result in a linker error, as shown in the previous program. The case number 2 is where two or more identically named functions or global variables are introduced into the same file. This will result in a compiler error. As programs get larger and use more identifiers, the odds of a naming collision being introduced increases significantly. The good news is that C++ provides plenty of mechanisms for avoiding naming collisions. Local scope, which keeps local variables defined inside functions from conflicting with each other, is one such mechanism. But local scope doesn't work for function names. So, how do we keep function names from conflicting with each other? A scope region is an area of source code where all declared identifiers are considered distinct from names declared in other scopes. Two identifiers with the same name can be declared in a separate scope regions without causing a naming conflict. However, within a given scope region, all identifiers must be unique. Otherwise, a naming collision will result. The body of a function is one example of a scope region that you should be familiar with. A namespace provides another type of scope region called namespace scope that allows you to declare names inside of it for the purpose of disambiguation. Any names declared inside the namespace won't be mistaken for identical names in other scopes. Unlike functions, which are designed to contain executable statements, only declarations and definitions can appear in the scope of a namespace. For example, two identical named functions can be defined inside separate namespaces, and no naming collision will occur. Namespaces are often used to group related identifiers in a large project, to help ensure they don't collide with other identifiers. For example, if you put all of your math functions inside a namespace named math, then your math functions won't collide with identically named functions outside the math namespace. In C++, any name that is not defined inside a class, function, or a namespace is considered to be a part of an implicitly defined namespace called the global namespace. In the example at the top of this tutorial, functions main and both versions of my function are defined inside the global namespace. The naming collision encountered in the example happens because both of our versions of my function end up inside the global namespace, which violates the rule that all names in the scope region must be unique. When C++ was originally designed, all of the identifiers in the C++ standard library, including stdcin and stdcout, were available to be used without the std::: prefix. However, this meant that any identifier in the standard library could potentially conflict with any name you picked for your or identifiers. Code that was once working might suddenly have a naming conflict when you include in a different part of your standard library. Or worse, code that compiles under one version of C++ might not compile under the next version of C++, as new identifiers introduced to the standard library could have a naming conflict with already written code. So C++ moved all the functionality in the standard library into a namespace named std, short for the standard. When accessing an identifier that is defined in a namespace, for example stdcout, you need to tell the compiler that we are looking for an identifier defined inside the namespace std. There are a few different ways to do this. The most straightforward way to tell the compiler that we want to use cout from the std namespace is by explicitly use the std::: prefix. For example, the : symbol is an operator called the scope resolution operator. The identifier to the left of the : symbol identifies the namespace that the name to the right of the : symbol is contained within. If no identifier to the left of the : symbol is provided, the global namespace is assumed. So when we say stdcout, we are saying the cout that is declared in the namespace std. And this is the safest way to use cout. Another way to access identifiers inside a namespace is to use a using-directive statement. A using-directive allows us to access the names in a namespace without using a namespace prefix. So in our application, when the compiler goes to determine what identifier cout is, it will match it with the stdcout, which, because of the using directive, is accessible as just cout. Many texts, tutorials, and even some IDEs, as in our example Visual Studio, recommend or use a using directive at the top of the program. However, used in this way is a bad practice and highly discouraged. Consider the following program for much clarity of my point of view. In this program, it will not compile because the compiler now can tell whether we want the cout function that we defined or the standard cout. When using a using directive in this manner, any identifier we define may conflict with any identically named identifier in the standard namespace. Even worse, while an identifier name may not conflict today, it may conflict with new identifiers added to the std namespace in future language revisions. This with the whole point of moving all of the identifiers in the standard library into the std namespace in the first place. In C++, curly braces are often used to delineate a scope region that is nested within another scope region. For example, a function defined inside the global scope region uses curly braces to separate the scope region of the function from the global scope. In certain cases, identifiers defined outside the curly braces may still be part of the scope defined by the curly braces, rather than the surrounding scope. Function parameters are a good example of this. The code that exists inside a nested scope region is conventionally indented one level, both for readability and to help indicate that it exists inside a separate scope region. Hope you guys enjoyed this tutorial. If you did, hit that thumb up button and subscribe to my channel, and see you next tutorial.